knows where it is. And then do 1 minus that. Because I saw that a few times on the, I can't remember which, the take-home quiz. I saw a few people give me just a real quick, just the probability I gave them for the answer, but that's for individual people, not for groups of whatever people that I gave you on that take-home. Yeah. 5 D. Okay. Let's build up on that number 5. Well, here, I'll tell you. I'll go ahead and give you guys the... There's no reason for me to hold on to this. I'll give you guys this answer key. The last problem, though, on your answer sheet won't be right. I changed it for this class. Yeah. So now that'll be just like that handout I gave you, the colorful handout. So you take the samples that you found and you find the means of each one.
So when the book says median, that is going to mean, because like for number 9 it said like finding the median.
Where are we at? Number 9? Yeah, for the funny thing is, I mean, I always forget to do that. For 2 data points, the median and the mean are the same. You're right, right? Because how do you find the middle of 2 numbers? You take the average. But if they're the middle of the numbers, then that must be the median. Cool? So it's funny, if they ask you to do the median, number 12. So is that really your question? Number 12, you've already done the work, basically, right? Yeah.
On 5C on our the Z-score is 1.645. Do we always have to find the average? I know you said it's
Only if it truly is exactly in between.
okay, so if we did just 1.64, it would be wrong on the test. If we did average, if we went to one below.
No. That number, 1.645, it's asterisked in the chart, right? It has an asterisk. Right? It's got an asterisk on it. So we'll see why later. That 1.645 will become one of the numbers we just know. It's one of the most used ones past 1.96. So whenever you see like a a confidence interval in the newspaper or something, they always use a 95% confidence interval. 95%, the z-scores catch 95% of the data, right? So it's always like a 1.96 z-score. But sometimes they use what was this one? Yeah, sometimes you use a 90%, which would be 1.645. Or these are 98, which would be 2.33. Or, you know, there's certain z-scores that will become really known to us over chapter 7 and 8. And that's one of them.
So for the test, do we need to know that?
Not yet. I mean, you'll see later. But on the chart, if it's asterisk, you should definitely use it.
Okay,
That's
so
a
just
different,
the two
it's a
that-
difficult word to say the past tense of. Asterisked. Yeah.
18 on 6.3.
So the first quartile with the IQ scores, right? All right. We've seen these IQ score problems before because they're normally distributed. And the funny thing is it's because we forced them to be normal, but let's go on. It says to find Q1. How would you draw Q1? Where would that be?
25%.
Okay, it's 25%, so where would that z-score be for that? Would that be a good IQ to have? Would you be proud of it?
No.
Not necessarily, right? It's below average. You've only got 25% of the population below you. So you'd have to be about right here. So this will be the 25% here, right? So that's step one, just drawing the picture correctly. Now what kind of problem is this?
X equals.
I love it. It's the backwards problem, right? You don't want to use the z-score because I'm going to be able to find the z-score from the area. They gave me a percentage. I can look up the z-score. So it's just doing this whole thing backwards. They gave me a percentage. I can find a z-score, and then I can create the x-score from the formula. So when you look up 0.25, what z-score is that closest to? 0.25 area. Yeah, let's see. Yeah, because the other side is 17 away. 2514, that's the closest area we can get, right? 0.2514, and that's for a z-score of negative 0.67. So if you're really not good at this, look up z-score of negative 0.67. You see that the probability is 0.2514. That's the closest I can get to 25%. Okay. I really, really desperately want you guys to understand there's a connection between z-scores and percentages, of course, right? If I start off, real quick, if I start off at a z-score like negative 4, there's basically nothing below it. When I get up to negative 3.5, like the book says, there's 0.0001 below it. So really all that z chart does is it progresses along and it keeps saying, oh wow, there's more below me now, because I just keep moving up and up and up. So by the time I'm about 2/3 of a step down from the middle, I've got 25% of the data below me. So I did this to this. Now I got to do this to this, and I can just use that formula there. Because think about it. The mean is 100. How do I get to this data point there? I've got to go down how many steps? What does it tell me how many steps to go down? What's the z-score? I love it. So what is the z-score specifically here? Negative 0.67, right? So that's why this formula makes sense. When I started at 100, and I would go down 0.67 steps. Isn't that exactly what this formula says to do? The mean plus z, well, z's negative, times the standard deviation. Because how do I get to a data point? I start at the mean, and I go this many steps. So really, it should make sense. Of course, I'm going to end up below the mean because I'm at the 25th percentile. I should have a relatively lower IQ then, right? So the formula makes sense. If it was a positive z-score, I'd start here and go up. Because then I have more below me then. Okay. So whatever you get when you do that, 2/3, 10, 90, right? You get a 90. Roughly. It'll actually be like 89 point something.
9.25.
All right, which is basically 90. Cool. I know numbers. I got to show off every now and then.
18 on 16.
Oh, so 6 we haven't done yet, really.
So 6.5.
The one about the vending machines. 18.
Yeah.
The one about the quarters. All right, this might be a good review in general because this is okay. This is one of those evil problems that they don't tell you directly what the question in math really is. They tell you the situation question, which, what do I mean by that? They tell you blah, 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 blah. Then they say part A says, if 280 different quarters are inserted into the vending machine, what's the expected number of rejected quarters? Number 18. So it's number 18, section 6.3, right? Oh, 6.5, sorry. This one? So they have a mean of 5.67 and a standard deviation of 0.062. So it's configured so we'll only accept those quarters between 5.55 grams to 5.790 grams. Now think about it. Why does this make sense? Why would it accept a quarter that wasn't the exact mean? There's actually a couple different reasons for that. Why? What happens to your quarters over time? They either get worn down or possibly they get something else stuck on them, paint. Right? They're still valid quarters. So it should, and plus beyond that, whenever they make quarters, is every single quarter exactly the same weight? Even there's going to be some variance. Right? It's not going to cut the metal perfectly. It's not going to do the imprint perfectly. It's going to be a little bit off. So it's going to be 5.67 plus or minus 0.00, whatever the hell. So of course it's got to have some tolerance for both those reasons. Right? They want to make it more difficult for people that try to put in there who knows what. So part A, this question is really kind of devious. And let me see if you guys can pick up on this. Part A has to do with the expected number of rejected quarters. Part B is different. Because it says, if 280 different quarters, what's probably that the mean falls between blah and blah. And some of you guys, I don't know if you're with me enough to really see the difference here, but like on the first thing on the practice test, I really want you guys to get this. The very first problem on the practice test, not the first problem, where'd it go? Oh, here, I'm sorry. The problem number 5, part B. And I've asked this kind of question before. So part B says, if 2,000 students are selected, how many would be expected to have a test score greater than 315? And how do I calculate that? Well, I already did the work. Number 1 on part A says the probability that X is greater than 315. Right? That's the percentage of all students who would be greater than 315. So I would just take that percentage times the number, N times P, right? The mistake some